So let's see how the actual process of applying that state works. Every node managed by Puppet has an agent running, and by default, twice per hour, that agent will talk to a Puppet master. Will first collect facts about the node, which is basic information like hostname, fully qualified domain name, IP address, which kernel, if it's a physical server or virtual machine, that kind of stuff. We'll send the facts to the Puppet master, and then it will request a catalog from the Puppet master. The catalog contains all the things that we want to manage on that node, and that catalog is generated for each node based on the facts and the Puppet code, your manifest that you have on the Puppet master. Once the Puppet master generates the catalog, it will send it back to the agent, and the agent will go through that catalog and say, okay, we need this service to be running. Is it running? Yes. We need this user to be present. Is it present? No. Okay, create this user. We need this file to have this content. Yeah. Once it's done going through the catalog, it will generate the report, and we'll send it back to the Puppet master. The Puppet master will use a report processor, and will do something with that report. By default, in Puppet Enterprise, that means storing it on a Puppet DB and make it available for you to browse using the Puppet Enterprise console. But it's, you can extend that and integrate reports with something else. That something else being whatever you need for your workflow. Everything you manage with Puppet is a resource. So for example, we have a file for the Apache configuration here, which is a resource. And we also have the HTTP, the Apache package is also a resource. You have a command line tool that allows you to inspect. And what you see here is actually Puppet code. You can, in many cases, you can copy and paste that into your manifest when you're starting to Puppetize your infrastructure. So it's quite useful to learn and to start. And it's also useful when you're dealing with a platform that you are not really familiar with. So how do you check if a package is installed in Solaris? I don't know. Puppet resource package, if you know the package name, Puppet will tell you if it's installed or not. So it also abstracts you from the specifics of the platform. So this specific Puppet code defines a user with a couple of attributes. So we'll make sure it's present, and the user ID and a group are the right ones, and also set the home directory. This piece of code works on any supported platform. So I can apply this same Puppet code in any Linux, Solaris, AIX, even Mac OS, and with a small change for the home directory, I can even apply this to Windows. And on top of that, you get error handling, audit, and reporting, which is something the old ways of writing custom scripts didn't give you. The problem is that managing resources one by one, it's not very useful. So let's say you want to manage Apache. For Apache, you need a couple of things. You need the package to be present, the configuration to be present with the right settings, and obviously you also need the service to be running. In Puppet, you can group those related resources into classes and abstract the application management that way. So in this case, we're building a configuration file using a template, and we're telling Puppet that the configuration has to be enforced. The configuration file has to be enforced after the package is installed. Why? Because the package probably has a default configuration, and we want to override that default configuration. So on top of that, you can group, the same way you group related resources into classes, you can group related classes into modules. So for example, you might have a class that manages the SSH client and another class that manages the server side of SSH. You can put them into an SSH module and manage both sides in one package. The advantage of doing things this way is that then you can reuse your code. You would treat your Puppet code as building blocks. So then using parameters to change the behavior, you can reuse and do different things with them. So in this case, we have 4 basic modules: security module, web server module, database, and an application server. We have 3 different types of servers, and then we can mix and match the security and web server modules to build a server that's actually a web server role, or a database server, or an application server. You're still using the same security module on all of the different server roles. So that reduces the code complexity, and it's easier to maintain. The other interesting thing is that your infrastructure is now managed by code. So that means that you can use the same tools that you use to manage your application code to manage your infrastructure. So let's say you use Git. You can put all your Puppet manifest in a Git repository and keep control of your infrastructure that way. So now you have your infrastructure managed like your code, so that means that it's version, you have historical log, very important for operations people is that you are able to very quickly revert changes that didn't go as expected. But for you guys here, the most important side of it is that since you have a version infrastructure, you can include that into your build pipeline. So that means that now you can test both your infrastructure changes with your application changes. So you know if your code will work after the new libraries are updated onto your systems. If something doesn't work, you don't have to wait until that change goes to production. You can test that in integration environment. So testing your infrastructure early on allows you to reduce outages and, of course, increase the confidence on your application as a whole. For that to be practical, you need a way to ensure that your Puppet manifest are working as expected. So you can use RSpec Puppet, which is an extension of the RSpec Ruby unit testing library to test your Puppet modules. So this would be unit testing. The way it works is that it passes input to your modules and generates a catalog and checks in the catalog that the things that you expect are actually there. So in this case, you're testing a firewall module, and you're passing some facts. It's the information that your module used to change its behavior. And then you check that ensure running is in the catalog. So you have your unit testing, but that doesn't mean that your code is actually going to work on a real system. So once you have your unit testing done, then you have to change to system testing. For that, you can use a tool created by Puppet Labs called Beaker, which is similar to server spec. The way it works is similar to the unit testing, but the main difference is that instead of just doing everything offline, it will spin up a virtual machine running the operating system you need. Apply your manifest using Puppet, and then go and check into the system to make sure that all the changes that you expected are actually there. So you first have your unit testing, which will give you an idea if the catalog makes sense. And then you have the proper system testing, so you can make sure that your code will work. So now you have your infrastructure puppetized. That means that disaster recovery is much easier. You just need to get the puppet master somewhere and start spinning up servers, and all your infrastructure will be rebuilt automatically. If you need to do a data saver migration, the same. Just need to change a few settings here and there, and you're done. If you need to build a new environment, the same. You're probably having to copy a few files, change a few settings here and there, spin up nodes, and Puppet will take care of the rest. How many of you are currently working in a dev environment that matches your production environment? Come on, how many of you? Using Puppet, you can get to something that's almost like your production environment. This is a major thing. This is almost like the holy grail of operations. Because the problem we have on the operations side is people get their code to QA, sign off, it's yours. And then you say, well, but this is not working. Why? I don't know. You tell me. Well, but it worked on my desktop. Yeah, but it doesn't work where it matters. So once you have the same code configuring your infrastructure everywhere, that means that that developer should be able to figure out that something is broken way earlier in the chain.
Can you take the production system and take the code as what is there in the infrastructure as a code and put it in another system? Or do we need to have the code that need to be maintained both in development and production?
The idea is that you have one set of Puppet code.
Yeah, I don't have Puppet code now. So I have the production system and development system. For a production system, I want to have the Puppet code as a repository.
You will have to write the Puppet code first.
Without Puppet code,
I
can get what is
out of the box, you are not able to lift easily the current state. There are ways where you can retrieve the current state with Puppet, but it will generate a lot of Puppet code which you don't need.
It's not possible other way. From code to infrastructure.
It's possible, but I wouldn't recommend doing it. So, we're going to have more questions at the end. So, now that you have everything, your unit testing, acceptance testing, you can tie this into Jenkins, for example, using the build pipeline plugin. And you can test your infrastructure and then deploy your application and make sure that everything works together. At the end of the day, what's really important for the company is that your code is actually running in your infrastructure. It's not good for the company having the file, but it worked here, it's your problem. No, it's not your problem, it's our problem. Our job is to make sure that your code runs in the infrastructure. So Puppet can help you there and make your life easier. So Puppet, you declare the state of your infrastructure. You don't tell Puppet, run this command. You tell Puppet, I want this system to look like this. You don't care about the details. Puppet will take care of that. You can use version control to keep track of your Puppet configuration. And for you, it's important that you can test Puppet, your infrastructure, along with your application code. We're going to have a quick demo now. These are going to be available later on with the slides. So currently I have here Puppet Master. This is a very simple demo. I know that there are a lot of people have never used Puppet before, so we're going to focus on basic Puppet usage. We have a Puppet Enterprise here with a Puppet Master and an agent running Puppet. I have a simple set of manifests here deploying a static web page, nothing fancy. So let's see. These are all the files that I'm using to manage this simple environment. This is on the Puppet Master. I have a production environment. That's a Puppet production environment. There we have a couple of modules. We have one that called profiles, one called roles. The idea is to abstract your infrastructure. So all your servers have common things. Like, for example, you use centralized authentication, and you have security settings, firewall. All that stuff is common to all your nodes. So the idea is that you start building profiles. You use generic modules that you can reuse to do different things. And then you use those generic modules to create profiles that do one specific thing. So in this case, we have two different profiles, base profile and web server. Then we have roles. The roles use different profiles to build a specific role. The role would be whatever you call your servers within the company. So if you're telling a coworker, oh, the web application server is down, he knows exactly what you're talking about. So that would be the name of your role. And finally, we have a module which I use to set up the content of the site. So let's see. This is a simple example, but this is pretty much what using Puppet in a real world would look like. When you're checking the roles, if you're using the roles pattern, a role is very simple. You just include a couple of profiles. So here we have a base profile and a web server. So let's see. What's on the base profile? So here I'm just setting up NTP. Time is important for many applications, so NTP is a very common example. The first line, what I'm doing is basically retrieving the name of the NTP servers from external data. So that's another important thing. You can keep your configuration data separated from your Puppet code. That's how Puppet allows you to use exactly the same Puppet code in different environments. This function called Hira, it's for a tool called Hira, which stands for hierarchical data. It's a tool that allows you to define multiple levels that it's flexible, so you can use to adapt that to the best way for your company. So if you have a hostname that gives enough information to decide which data center it's located on, etc., you can use that to change the settings. So in this case, we have only one layer because it's a simple example. So we use that information to set up the NTP. Then we have a class that the only thing that does basically is retrieve the files from a Git repository and put them in a location. So finally, let's go to modules, profiles, web server. So this is where you define your application. So in this case, I'm retrieving 3 different variables from the external configuration data. Remember, that's the part that you can use the different layers to set things differently depending on which environment you're working on. Then I'm using a generic module that installs Nginx. I'm deleting a file that I don't need, which is the default vhost. Then created a new vhost using, again, the functionality provided by this third-party module. I didn't have to write it. It's available on the Puppet Forge, which is a repository of Puppet modules. And finally, I called my generic static website class and passed parameters to build a specific website. So, for example, this is the here data, so I'm going to quickly change this. We don't have much time left. So what I did was change the branch I'm using from Git. So let's quickly go here. We have this side here. Now I'm forcing a manual run. Puppet runs automatically twice per hour. That red message is a bug in a module I'm using. So now we see that it changed the revision number of the static content. And now I refresh the web page and change. What it took was 1 line in one simple file. And if I had 10 servers using this, that was all I need to do to change on all of them. So I don't think we have time for questions, but if you need to contact me and you have any questions, we're out there. That's my contact information.